Hi guys, so for this video I picked out a pretty difficult exam question on logarithm equations. So we're going to use both of these rules. One that when the base is the same and you subtract logarithms, you're dividing the insides of the logarithms. And when there's a power for a logarithm, you can bring that forward as a coefficient and vice versa. So first we want to form two equations of y and x because that's what simultaneous equations are. If we take all the log terms to one side and keep all the terms that don't have log on one side, let's do that first on the top equation. So we have log base 2 of y minus 1, what's already on the left hand side, and we're going to take away log base 2 of x from both sides. After you've done that and you make the right hand side equal to 1, you can realize that, well, because the base is the same and we're subtracting logarithms, we're just dividing the insides of the logarithms. So this will become log base 2 of everything that's inside the first logarithm, y minus 1, all divided by everything that's inside the second logarithm, x. And you can make all of that equal to 1. If you're stuck on what to do at this step, there's a template I'd like you to remember, which is that if 10 squared is equal to 100, then log base 10 of 100 is actually equal to 2. This helps you in the positioning of variables in a logarithm. What it means is that you can bring the base forward, just like it's brought forward here. So let's do that here, 2. What's on the right hand side, you can make that a power. So here you can make 1 as a power, and you can make it equal to what's inside of the logarithm. So you can make it equal to y minus 1 all over x. 2 to the power of 1 is just 2, so we're just going to leave that as it is. Multiply both sides by x and we get 2x is equal to y minus 1. Add 1 to both sides and we get y is equal to 2x plus 1. That's what equation you can get from the first sort of logarithm. Moving on to the second logarithm, again we're going to apply the same process because there's two terms with log base 3. Let's take all the terms with log base 3 to one side. So we're going to keep the one that's on the left hand side as it is, and we're going to subtract log base 3 of x from both sides so that it appears on the left hand side and it becomes just equal to 2. We can't quite divide these logarithms yet because there's a 2 in front of this logarithm. To remove that 2, we can reverse this rule here and we can bring the coefficient forward as a power. Now that there is no 2 before the log, you can divide the insides of the logarithms because the base is the same and you're subtracting the logarithms. We keep the base the same and we divide the insides of the logarithm, so it becomes y squared over x. Sorry, just to write that out again. And you can say all of that is equal to 2. Once you form this expression, now we use this template again. We bring the base forward just like I brought 10 forward there. What's on the right hand side, that becomes a power, so 2 becomes a power, and you make it equal to what's inside the logarithm. After you've done that, you can establish that 3 squared is just 9. You can multiply both sides by x, so y squared equals 9x. And now that you've got two equations in terms of y and x, you can substitute one into the other or equate them in some format to find the values of x and y. In this case, I think it's easiest to put y equals 2x plus 1 all into this equation. In that case, y squared becomes 2x plus 1 all squared, and you can make it equal to 9x. When you square a bracket, that's the same as just multiplying the bracket by itself. So I'm going to write this out as 2x plus 1 multiplied by itself again. We can expand out. 2x times 2x is 4x squared. 2x times 1x is 2x. 1 times 2x is another 2x, so those add to give 4x. 1 times 1 is 1, and you make all of that equal to 9x. To make the right hand side equal 0, you can then subtract 9x from both sides, and you get 4x squared minus 5x plus 1 is all equal to 0. Now 4 times 1 is 4. Two numbers that multiply to give 4 but add to give minus 5 are minus 4 and minus 1. And you put that in a bracket with 4. So you can use whatever method you normally use for simplifying here. In this case, we're going to put minus 4 in one bracket and minus 1 in the other bracket. I put 4x at the beginning of each bracket because there's a 4 before the x squared. Now you're probably wondering, but 4x times 4x is 16x squared. That's why we simplify both brackets as much as possible in this last step. When you do that, you can divide every term in the first bracket by 4 to get x minus 1. And every term in the second bracket, we can just sort of leave as it is. From there, you can establish that the first bracket equals 0 only when x is equal to 1. And the second bracket equals 0 when x is equal to a quarter. So those are your two solutions for x. X equals 1 and x equals a quarter. Oops, sorry, that's a whole other question. Let's finish this off here. So x equals 1 and x equals a quarter. Now we need the respective y values for each of those x values. I'd recommend you just get one of these equations. I think this one's the easiest one to use. And just substitute both of these x values into y equals 2x plus 1. So let's do that. When x is equal to 1, y is equal to 2 times 1 is 2 plus 1 is 3. So y equals 3. Whereas when x is equal to a quarter, well, 2 times a quarter is 2 quarters, which is just a half. A half plus 1 is 1.5 or 3 halves, however you want to write it. And these are your solutions to the simultaneous equations. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.